Hello, good morning. Just a quick recap of what we have done so far. Um, for the graphs of irrational functions, um, there are a couple of things that we always have to make sure that we check when we get questions. So some of the things such as the trying to see if there's common factors. Um, and the second thing is finding all the intercepts, including the x and the y intercepts. So what makes the numerator turn into 0, the p of x? They are your x-intercept. For the y-intercept, you just set the x is equal to 0 and solve for the y. And the next thing that we are checking is also finding what the vertical asymptote, the VA. So the VA happens when the Q of x, your denominator, is equal to 0. Okay? And lastly is to find the horizontal asymptote, the HA. And for the HA, there are 3 subcases, and we have already talked about the first 2. So the first one is when the degree of the numerator is less than the degree of the denominator, then you always get a HA at y equal to 0. And when the degree of the numerator is equal to the degree of the denominator, then your HA is always equal to y equal to the ratio of the leading coefficients. All right? So those are the things that we talk about it from my last video. So today I'm going to finish it up the third subcases of the horizontal asymptotes, and this is when the degree of the numerator is greater than the degree of the denominator by more than 1. So in such a case, then there will not be any horizontal asymptote exist. Okay, so by more than 1, this is very important because there will be another case later when the denominator, the degree of the numerator is greater than the degree of the denominator by exactly 1. Okay, so that is another case that I'm going to cover today. So what do we mean by the degree of the numerator is greater than the degree of the denominator by more than 1? So let's look at one of the example down here that I have done for you. Okay, so I have a function k of x that is equal to this 2 factors divided by this quadratic down here. So if you look at the degree of the numerator, so this is a x squared, this is a x squared. So when you multiply these two together, you get x4. So this question really is the degree 4. Okay, so this question really is a degree 4 divided by a degree 2. So the degree of the numerator is greater, 4 is greater than 2 by more than 1. Okay, so this is a good example to show you. And of course, like what we have done before, everything, the numerator or the denominator, everything has to be in fully factored form. So in this case, after I factor the denominator, I get a x minus 1 to the power of 2. Okay, you can separate them or you can combine them into one bracket, which is fine. So from here, I see that there's no common factors, so there will be no whole. The 0, so I'll be looking at what makes the numerator turn into 0. For the x squared plus 3, there's no 0 coming from here. If you set this equal to 0, you know that x is undefined. So there's no 0 coming from x squared plus 3. But for the x squared minus 5, yes, there will be 2 0, and the 0 is equal to plus and the minus of root 5. Okay? So how do I get plus and the minus root 5? It's very simple. When you take the x squared minus 5, set it equal to 0, and then you can solve for the x. So x is equal to plus and the minus of a square root of 5. Okay, so that is where the 0 is coming from. Okay, so when you set this equal to 0, you get x is equal to plus and a minus root 5. Okay, so that's why I have the 0 at for this. And y-intercept is when you set the x is equal to 0. So when x is all equal to 0, what is left is the 3 times the minus 5 times the positive 1. So that's why you're getting y equal to negative 15 over here for the y-intercept. Okay? VA is what make the denominator turn to 0. So you get a VA at x equal to 1, because if x is equal to 1, that denominator is turning to 0. Okay? Now, in this case, because it's a degree 4 divided by degree 2, therefore, horizontal asymptotes does not exist, so it's none. Okay? So degree 4 over degree 2, so it's none. And when you look at the whole, all this information, if you plot it on your graph, so you have a minus root 5 here, a positive root 5 over there, and a y-intercept at negative 15, and a vertical asymptotes at x is equal to 1. So all of this. So you make sure that you have everything on the graph. Now, how do I decide where to draw my graph? Is that I need to have those key points, make sure that your graph has to hit those key points on the left side, and that key points on the right side of the vertical asymptote. But the best thing to do is to come up with the factor table. Okay, remember I talked about the factor table. You are in the factor table. You always take the zeros and the vertical asymptote, those values for the zeros and the vertical asymptotes, which is a plus and a minus root 5 and a 1. You line them up here on this line on the top. You line them up in an ascending order. So start with the smallest, and the biggest go in here, and then you put all the factors down here. Okay? Now, in fact, I don't really have to put in the x squared plus 3, but I want to show you that because this one has no 0. So even if you put it down here, everything over here has to be positive, because no matter what you put, the values of the x, everything turn into a positive. Okay? Same thing as the x minus 1 to the power of 2. Anything to the power of 2, you don't really need to include it on your factor table. So this two row here, this and this, is not necessary to put it there. But I just want to show you, even if you put it there, then everything is positive. Okay? When everything is positive, it does not change anything that you do underneath. Okay? So for the factor table, in fact, I should only put in x squared minus 5 over there. Okay? I only need to put in the x squared minus 5. Now, for x squared minus 5, then it's difficult for us to see, oh, where do I get plus, minus, minus, plus from? For this particular example, you have to sub in a value. For anything that's less than a negative root 5, let's say a negative root 9, like a negative 3, if you put in a negative 3 over here, you see that a 9 minus 5 will give you a positive. Okay? Any number between a negative root 5 and a 1, let's say a 0, if you put in a 0 there, you get a negative. That's why this one is a negative. And between a 1 and a root 5, let's say if you put in a 2 in between. So 2 is 4. 4 minus 5 is a negative. That's why you get a negative. And anything greater than root 5, okay, such as 4 or 5, and you know that when you put in a 4 or a 5 here, you will get a positive. Okay? So some people might find this is a little bit more complicated, but you can also do it another way to get the plus, minus, minus, plus over here. Okay? So let me just show you another way that I can do. Okay? And without putting the other factors there, I can also show you if I put in x squared minus 5 over here, okay? But I will do it two different ways. Because this is a x squared minus 5, I know that there are two zeros. So one of the zero happen in here, and one of the zero happen in there. So if I do this factor here with the two row, so I get a negative, positive, 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 and a negative, 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 positive here. So as you can see, I'm still getting the same answer. Positive here, minus here, and positive down here. Okay? So there are two ways that you can do when you have a factor that has an x squared minus something. Is either you do it two rows, or you pick a number for each of the interval. You sub it in there, and to see what sign do you get over here. Okay? So just like what I did in the first place. But you should still get the same answer. Okay? So some people might find this way is easier because you know that there are two zeros. And you can just easily put in the sign. The left of the zero is negative and the right of the zero is positive. Okay? But in this case, you have to do it two rows. Okay? Unlike the single factor where you only need to have a one row of a sign. But right now you need to two. Okay? So what happened here? Anything less than a root 5 over here on the graph is positive. So that means my graph should be on above the x-axis, above here, not down here. Okay? But after I pass the negative root 5, so in between a negative root 5 and a 1 in here, I should have a negative, so it should be down here. So it makes sense because I have a y-intercept here and the vertical asymptotes. So I pretty much know that my graph is going to be something like this. Cutting through, okay, cutting through here, but then slowly approaching to the vertical asymptote. So where will the other piece go? Well, this has to be with the arrow that's pointing up because you cannot turn. If you turn, that means you're going to cross the x-axis, but you don't have another zero up here. So this graph has to be like pointing upward with the arrow. I don't know where it goes, and I don't care. As long as I'm crossing this one here. So less than negative root 5, positive. Between negative root 5 and 1, I have a negative. Okay? Now, between 1 to root 5 is a negative. So that means I must have something that is going this way as well. Okay? And crossing the 0. And after root 5, I'm going up. Okay? And again, this piece has to be pointing up because there's no horizontal asymptote. So you're not coming down here again. So it has to go up. Same as the other sign as well. But the other piece has to come down because of the negative interval and has to go approaching to the vertical asymptotes. Okay? So this will be my example for the subcase number 3 for the horizontal asymptotes. Okay? Let's look at quickly. Let's look at quickly my my last point. Well, I'm done with the horizontal asymptote, but there's also one more asymptote that we need to pay attention to. And this is case number 5, which is finding the oblique asymptotes, OA. Oblique asymptote, the word oblique means it's a line that is not vertical, not horizontal, but it's the slanted with the slope. Okay, oblique means it's a line with a slope. And that is when the case is when the degree of the numerator is greater than the degree of the denominator, by exactly 1. Okay, so that kind of covers all the case that we might have by exactly 1, meaning same as the example on your handout, example A. when you have a degree 2 divided by a degree 1. So degree 2 and a 1 is exactly graded by 1. Okay? So when you factor this into a factor form, so you get x plus 2, x plus 1 divided by x minus 1. And for this one, you see that there's no common factors. So x plus 1 and x minus 1 is not a common factors. So there's no whole. And the 0 is what will make the x plus 2, x plus 1 turn into 0. So I get a 0 at negative 2, negative 1. And the y-intercept, when you set all the x equal to 0, you get a negative 2 over 1, which is a minus 2. Okay? Vertical asymptotes down here, what makes the denominator turn into 0? So x minus 1, x is equal to 1. And there's no horizontal asymptotes because the degree of the numerator is greater than the degree of the denominator. So no horizontal asymptotes. Okay, but because the degree of the numerator is greater by the degree of the denominator by exactly 1, therefore there will be an oblique asymptote. So how do I get the oblique asymptote? Well, we need to use the long divisions method. So take the numerator divided by the denominator, but using a long division method. Okay, no synthetic. When you divide this, and you will see, you will get a quotient of x plus 4. What happened to the remainder? Well, I don't care what remainder do you have, whether it's a 0 or whether there's something left here. I don't care. But once you finish dividing it, your quotients will be your OA. And this quotient here will becomes a line that starts with the y equal to x plus 4. Okay? And this oblique line has to be drawn, same thing with the broken line. Okay, and this line will have a y-intercept at 4 and also x-intercept at negative 4. Okay, so those has to be accurately drawn on the graph. So with the vertical asymptotes, with the oblique asymptotes, and with all the zeros, negative 2, negative 1, and the y-intercept at negative 2, okay, so now we have to figure it out. Where will my graphs of this rational functions be? Will be something over here, something down here, or something over here, or something over there. So obviously, with the region where you see all those intercepts, then you know that your graph has to be somewhere here for this part. But what about the other parts, right? You don't know whether it's up here or down here. Sometimes you can see, oh, it wouldn't be down here because I don't have another 0 down here. Then obviously your guess will be pretty accurate by looking at where you should be crossing or where you shouldn't be crossing, and then you know that. And you must have something up here, okay? But it's always better to use the factor table to make sure that you are in the right positions. So I'm creating this factor table down here. Again, I'm using only the zeros and the VA values, the negative 2, negative 1, and 1. So I have a negative 2, negative 1, and 1. And for the factors on the side, then I have to list all of them, x plus 2, x plus 1, x minus 1. So none of them has a power of 2. So that means every single one, I need to list them, okay? And then I'm going to put in the 0 and where we'll make each of the factor turn into 0. So I have a 0, a negative 2, negative 1, and a 1. So I start to fill it out like negative, positive, 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 negative, negative, positive, positive, and negative, 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 and a positive. So at the end, I will have a result of negative when x is less than negative 2. So when x is negative 2 over here, I should have a negative, so it's below. So that means I must have something like this. Well, because of the asymptote, I know that the tails of the graph has to go approaching to the asymptotes. In between negative 2 and negative 1 over here, I have positive. So that means this graph must be going up. must be going up, hitting this 0, okay, coming down to hit this 0. So now between -2 and -1 is above the x-axis. But after -1, so between -1 and 1, so between here to here, I'm getting negative again. So I need to come down. Then obviously I have to come down because of the y-intercept. So I'm coming down. I'm coming down, crossing this y-intercept, okay? But between -1 and 1, I also have to be negative. So it has to come down continuously and go approaching to the vertical asymptotes. So I'm done this part. And then when it's greater than 1, I have positive. So positive, I have this region. But I cannot have anything here because I don't have another 0 down here. So it has to be somewhere up here where it's bounced by the oblique asymptotes and the vertical asymptotes like this. So it wouldn't be up here because if I have something down here, then this piece, I have to cross the x-axis. And because I don't have a horizontal asymptote, so it wouldn't be like going like this as well. Okay? So that is the look of this graph. Okay? So that is the look of this graph. If you look at how it match, everything should be matching your table of values. Okay? Everything should be matching your table of values. Let's do one more example so you can see it better. Okay? So now you have example B where you have a degree 3 divided by degree 2. So again, this is the degree of the numerator and the degree of the denominator has a exactly difference by 1, greater than by 1. And so when you turn everything into a factor form, you find your zeros at 0, okay, because you only have one terms there. Y-intercept is also 0 because your numerator is a 0. VA, so you have x equal to 2, x equal to -1. And you don't have any horizontal asymptotes because this is greater. And so OA, you will get oblique asymptotes. So when you do the long divisions, so x cubed divided by x squared minus x minus 2. So you need to fill in the 0 if you don't have any other terms, okay? But after you do your long division, your quotient is equal to x plus 1. So therefore, your oblique asymptote is going to be equal to x plus 1. Okay? So x plus 1, if you look at what I did already over here, x plus 1, y equal to x plus 1 is a line with the y-intercept at 1 and x-intercept at -1. So those are the key points that I need to see clearly. And with the two vertical asymptotes at x equal to -1, x is equal to 2, and the x and the y-intercept at the point of origin, 0, 0. So those are the only key points that I can get my graphs ready, okay? Get my graphs ready. And of course, I have to rely on my table of values down here, up here, okay? So between the zeros and the VA, I have a 0, 2, and -1. So -1, 0, and 2, I line them up all here, okay? And I write the factor, x cubed, x minus 2, x plus 1 over here. And I put in all the 0 for each of the factors, okay? X cubed will turn into 0 at 0. I'm sorry, my ink is dying. So this is a 0. This is a -1 over here, okay? And so I have minus, 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 positive, positive. And for x minus 2, I have a 0 here, so it's a minus, minus, minus. This is a positive. X plus 1, I have a 0 at -1, so minus, positive, positive, positive. Okay, so I totals up. So this becomes a negative, positive, negative, positive. Okay, so I know that anything that's less than -1, I should have a negative interval. So because of the oblique asymptotes and the vertical asymptotes, so I know that my graph is going to be like this. One tail's approaching to the vertical asymptote, the other tail's approaching to the oblique asymptotes like this. And between -1 and 0, between -1 and 0, I should have positive. So that means between negative and 1 has to be positive. Am I doing it right? Yes. So here, I should have this in negative, so positive. Oh, because this one has to be a positive, and I don't have any y-intercept down here. So that means I have to somehow, cross the oblique asymptote. This is the point of origins. Yeah. So oblique asymptote is another asymptote just like the horizontal asymptotes, where you have to cross. If you have a good reason to cross, then you have to cross. Now, why am I crossing it? Because according to my factor table, between -1 and 0, the graph must be in the positive interval. That means it has to be above. So I have no other choice, because if I don't cross, then I will end up with getting another y-intercept, which I don't have it. This is my only y-intercept, okay, at the point of origin. So I have no other choice but crossing it. But after between 0 and 2, I have a negative. So that means I must be going down here like this and go approaching to the vertical asymptote like this, okay? So it's like a little cubic. Well, because the numerator is x cubed. So you can see that this is where the cubic look is happening. And then anything that's greater than 2, I'm supposed to have a positive interval. So again, it wouldn't be here because I don't have any horizontal asymptotes. So I cannot create another 0, or I cannot go approaching to the x-axis. So that means to be in the positive interval, then my other graph has to be like this, approaching to the vertical asymptotes and also approaching to the oblique asymptote like this. Okay, so some of this graph, you might think that, oh, the shape looks funny, but that is the things that we have to do when we have to follow all of this. Okay, so this covers up everything when it comes to the graphs of the rational functions. Okay, so between the vertical asymptotes, horizontal asymptotes, now you also know that sometimes it's quite possible to have oblique asymptotes.